going to be doing a little intro to quadratic equations. So a quadratic equation is just any equation that can be written of this form. F of x equals ax squared plus bx plus c. And the only requirement is that a can't equal 0. So we've been graphing these, but we just did a little intro. So today we're going to do a little bit more with how the equation actually works. So I just wanted to give you some examples of what a quadratic equation looks like. So one example, the basic example, is just x squared. So a non-example would be something like the absolute value of x. This is not of the form ax squared plus bx plus c. A, b, and c can be any numbers, except they can't be 0. Another example would be, let's say, g of x equals 3x squared minus 17x plus 57. So here the a is 3, the b is negative 17, and the c is 57. A non-example might be x cubed minus 3x squared plus 57. So because this isn't of the form that's up here, it's not a quadratic equation. So let's just look at these and decide which one of these is a quadratic equation. So because this is of the form ax squared plus bx equals c, this is a quadratic equation. So is this one. It's just that here both the b and the c equals 0. Here this is not a quadratic equation because it is not, the a here would be 0. This one is also not a quadratic equation because it's not of that form here as well. So now the reason that this one, the last one, is a quadratic equation is because if I FOIL this out, I would get 3x squared plus 8x minus 6x minus 16. And if I simplify that, I would get something of the correct form. 3x squared plus 2x minus 16. So a is 3, b is 2, and c is negative 16 for this particular example. So I just wanted to go over some basic vocabulary with quadratics. So if this is our function, 3x squared minus 4x plus 7, 3x squared is referred to as the quadratic term because it's the term that has the x squared in it. Negative 4x would be the linear term because it just has a power of 1 on the x, like all lines do. 7 is called the constant because it doesn't have a variable in it. It's just a constant number. So let's do our joke of the day. So it's a little bit long. But our joke of the day is there's a sarcastic teacher that gets up in front of the classroom and says, if there are any idiots in the room, will they please stand up? After a long silence, one freshman rose to his feet. Now there, mister, why do you consider yourself an idiot? Inquired the teacher with a sneer. Actually, I don't, said the student, but I hate to see you standing up there all by yourself. Okay, so here let's try to identify the quadratic term, linear term, and the constant term for each quadratic function here. So here, the quadratic term is 5x squared because that's the term that has the x squared in it. The linear term is just 0 because there's no term that just has an x with a power of 1. And 8 is the constant term. So now let's try this example. So for this one, I would have to FOIL this out before I'm able to decide what each of these terms is. So after FOILing it out, I just have to simplify. Our quadratic term would be negative 2x squared. Our linear term will be x, and our constant will be 3. So I just want to make sure that you guys are familiar with the term coefficient. So the coefficient is just the word that we use for the number that's in front of our variables. So for example, the coefficient of the linear term for the first example is just 0 because it's the constant that's in front of the x. The coefficient of the linear term in this example is 1. The coefficient, just so that you understand, the coefficient of the quadratic term in this example is 5. And the coefficient for the quadratic term in this example, I'm going to let you guys answer for your question after the video. So hopefully you guys are familiar with what x squared looks like by now, but just in case, if you don't know what a graph looks like, you can always just plot points. So if we plot -3, -2, -1, 0, 1, 2, and 3, and plug them into our equation, we're going to just get 7 points. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So in the last video, all we did was we found just a rough sketch of what the shape would look like of a quadratic graph. Now we're finding a more precise shape of what that would look like. So after you plot these points, you can get a precise idea of how this U is curved. So now that we're going into this a little bit further, you will be responsible for knowing just more than those 3 points that we did last time. So when you're using your graphing calculator, if you have one at home, you can use this. But I just wanted you guys to get an idea of what each of these graphs look like. So I just went ahead and graphed this on some software that I had. So for the equation y equals -3x squared plus 2x minus 1, that graph just looks like this. So if you can see that it's a little bit skinnier and it's facing downward. If you look over here, I have the equation y equals 5x squared minus 4. If I graph that, you can see it's facing upward, the U is turning up, and it's also skinnier than a normal parent graph. If you look at this graph, y equals 2x squared plus 1/2 x, then this graph, it's a little bit skinnier than normal, but it's wider than the previous two. The reason for that is because this number, the quadratic coefficient, is 2 here. Oops. Whereas the quadratic coefficient in these was further away from 1. If you look at this last example, that graph was wider than the previous examples because the quadratic coefficient was further from 1. Now, I would also like you to know when these graphs are facing downward and when they're facing upward. So maybe you're able to find some prediction here. But basically, when A, where the quadratic coefficient is positive, the parabola opens up, and the graph has a minimum value, meaning that the bottom of the U is the lowest value that you can get. When A is negative, the parabola opens down and has a maximum value. So for this example here, our first example, my A equals 2. So that means that my graph is going to open up, and it will have a minimum. For this example, my A equals -1, meaning that my graph will open down, and I will have a maximum value. And that's it for our video. Don't forget to answer the questions. Oh, also, our student of the day is Erin Rundle for getting 100 on all 3 assessments that we did in class today. Good job, Erin.